formatting and coercing data. One thing to throw out there is that DataWeave has an extensive documentation. You can find it at the link that you have here on the slides, or if you just do a quick Google search for DataWeave documentation. Do make sure you're looking at the newest version, which is 3.8, at least at the time of this recording. Inside of the documentation, there's lots of details around formatting operators, more than we'll cover in class. As you can see, the input on the left, name max mule, and on the right, the transform shows n, in which we are mapping upper and running dasherize. So we have effectively two formatting operators we're running, one which is making max mule uppercase, and dasherize, which is changing those separation characters, in this case underscore, to a dash. Using the as operator for type coercion. One really common operator that you're going to see is the as operator, especially when trying to convert between types and even custom types. As an example in the top here, if we wanted to change the price key's value to payload.price, but make sure that .price came out as a valid number, we could say as number. We could say price value.price as number, and then specify a specific class as well. For example, if we wanted to ensure it comes out as a double rather than a long or integer. The defined types include string, number, boolean, object, which would be one of your own types, array, date, time, time zone, date, time, local date, time, period, regex, and a few more. Once again, if you're interested in a lot of these different conversions, you should check out the DataWeave documentation, specifically the section around type coercion tables. Using the format operator patterns. So, if we want to do some more formatting-oriented changes, we can use metadata format schema property to format numbers and dates. SomeDate as date time, for example, will specify that we want it to be a date and specify after that exactly the format we want it to be in. In this case, 4-digit year, 2-digit month, 2-digit date, hours, and minutes. For more details on formatting patterns, check out the basic Java formatting around date-time formatter and decimal format, as these are what drive what DataWeave is going to be doing from a formatting perspective. Now let's get into walkthrough 10.5, coerce and format strings, numbers, and dates. In this walkthrough, we'll explore the DataWeave documentation, coerce data types, and format strings, numbers, and dates. Let's get started. Back in Anypoint Studio, let's go to Help in the menu bar, and let's click What's New in Anypoint Studio. From here, we can click the Detailed Release Notes, which will be an easy way for us to open up the documentation. In the left navigation, let's open up the Mule User Guide, go to the Developing category. Inside of Developing, go to Transformers, and then from Transformers, choose DataWeave, and then DataWeave Operators. All right. With the Operators section selected, we can see the topic navigation on the right side. As we click on these different links, it will take us through. Let's go ahead and open up the As category inside of here. So I'll do a quick search for As. Might just be easier to scroll down. So type coercion using As. And as I scroll down inside of here, we can see some different details about type coercion. Now we can scroll inside and see some different examples, such as type coercion as a string. You can see it running through some of the different formatters and different items like that. In this page, you're going to see a lot of different information about different coercion pieces. There's also a link if you search for the type coercion table. And inside of the type coercion table link, you can give this a click, and this will give you some information about all the various type coercions that can be done, along with some of the different property information as well that it supports. Now let's return back to Anypoint Studio. We'll leave this dialog if it's still open. And from Anypoint Studio, let's double click, if not we're not already selected on it, the transform message inside of post multiple flights flow. Now let's change our DataWeave expression to return objects that also have a property called plain equal to the value of the input plain type values. To do this, we'll go underneath price and we'll add another element in, and we'll say plain, and specifically we will say upper, and then ask for plain type. Now in this case, you can see the uppercase that it puts in for these misspelled Boeing airplanes inside of here. All right, so now we're pushing this through the upper to make sure that it goes through that operator. Now, what if we want to coerce a string to a number? So we can see inside of here the price, which is coming out as string. We can go into that price and say as number. And with that in place, you can see the output coming out as an integer inside of here. Now, if we want to make sure that this number is a specific type, we can say number just as we did, and then we can open up this property here where we say that the class should be java.lang.double. And now it ensures that the price is effectively printed out as a double in all cases rather than just an integer. Now, what if we also want to format this number? Well, what we can do here is remove the coercion from double. And to format the number, we can put it back inside of string format here. And inside of string format, we can say format and say hash, 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 wrap that in double quotes. Okay, just got to clean up the double quotes here real quick. And now we can see the format being put in place. So it goes from number back to string and has this 3-digit format that gets printed out as well. All right, now if we want 2 decimal places, we'll go into format once again and do dot hash hash. And you can see the 2 decimal places that are input when they're available, such as 199.99. Okay. Now, if we go inside and we want to ensure that these are effectively .00 type prices, we can go in and inside of the format, we can say 00 at the very end for the literal. And with .00, this will ensure that things like 400 have the .00, 283, and so on, but of course respect the decimal places that are in place for things like 199.99 that actually had a value there. All right. Now let's see if we can add a date field inside of here. So at the end of plain, we'll put in date, and we'll put in the value of departure date inside. Now with departure date here, it of course comes as a string by default, but we can change that. Let's say as date to ensure that it actually gets written as a date. Now initially it's going to tell us that it can't coerce a string to a date. Well, this effectively means we need to format it. So let's put a format at the very end to let it know how it can parse this date. In this case, let's say we want to format this as YYYY, so full year, MM for month, and DD for day. And now it's actually capable of constructing this date object. And since it is a Java date object in this case, downstream we have a lot of flexibility about altering this date and doing different work with it. All right, now with our date in place, let's say that after we format it, we want to make sure it's a string again because some downstream system or something needs it to be a string. So once again, we can just add another as in here and convert it back to a string after the fact, in which case you'll see it puts in these dashes in between the format. So taking this even a step deeper, if we want to change the string format of this date, that is also possible. We can go to the end of the string with curly braces once again and say that we want this format to be, and let's say in this case we want MMDD and then 4 Ys, and this will ensure that we specify 3 letters for the month, so October OCT, the day, and the 4-digit year inside of here. So it's smart enough to then translate that back to a string with the respective date format that we want.